Now for exercise 17, which reads, two closed loops, A and C, are close to a long wire carrying a current I. And so I drew it here. And you can ignore the orange for now, that comes in as we talk about part A. So we have this wire coming across the middle, carrying current I in that direction, towards the right. And we have closed loop C at the top, which is kind of a square shape, and closed loop A at the bottom, which is more of a circle. Now the shape of them really isn't important, just the fact that they're closed loops. So in part A, it asks, find the direction, clockwise or counterclockwise, of the current induced in each loop if the current is steadily decreasing. And so part A, we have di dt being less than 0. So the current I is steadily decreasing, which means that the change in current is coming this way, and so the induced magnetic field around the rod is opposed to that change, so it's going in the initial direction of the charge, and it has this induced magnetic field curving around the wire. As it curves, it's coming up clockwise into loop C, or rather, sorry, it's coming up out of the paper into loop C, and it's going into the paper at loop A. And so if we consider those as the directions of this induced magnetic current, magnetic field, we'll see that for A, we must point our thumb into the paper to determine where its induced EMF and current would go due to this induced magnetic field. And so we see that it would actually curve clockwise. As we come around, back coming out of the page with C, we turn it this way and see that it would turn counterclockwise. So that's the answer for A. It's clockwise for A, that's going into the paper and turning, and counterclockwise for C. And for part B, it asks, while I is decreasing, what is the direction of the net force that the wire exerts on each loop? And asks for us to explain how we obtain the answer. And so it's actually imposing an inward pull on those loops, because let's consider the opposite first. If the current was increasing going this way, it'd be pushing out on everything around it. But since the current is decreasing, it's actually pulling on the objects surrounding it. And so that is a reasoning there, that as it is losing current, it tends to pull on the objects around it.